Coneo. Hello, JPZ. Today we're doing some more LeetCode. And we're doing it in JavaScript. If I had a choice of languages, I probably wouldn't be using JavaScript for this, but anyway, these are like programming interview questions, and sometimes the interviews ask for a specific language, so that's what's going on. Anyway, hello. Let's get some music on. The Nintendo 64 Jungle Mix, just like when I was doing the game jam and stuff. Anyway, I don't really talk much about my professional life and like code stuff. I do some code stuff on this channel, but like anyway, all you need to know is I'm doing some interview prep, and we are solving some programming questions, and we're doing it in JavaScript. In JavaScript, not TypeScript. No types. No type annotations, just JavaScript. I kind of haven't touched this language in like I guess I wouldn't say I haven't like touched it, because it's still a web browser thing, but I haven't like seriously written any JavaScript in a couple of months. So this is kind of me brushing up on some skills I haven't used in a while. I got filtered when I tried to study coding, but neocoding is always fun, even though I don't understand anything. It's good, as long as you're having fun. As long as I'm having fun. Am I having fun? I don't know. JavaScript's a little painful for me. Recently I've been learning Rust, actually, and in terms of like strict type checking, Rust is the complete opposite of JavaScript in that way. So coming back to it's been kind of a like dunking my head in a bucket of cold water or something. Rust syntax is wacko. Hello, 0T4U. It's a pretty unique language. It's got a lot of interesting things. Borrow checkered, lifetimes stuff. I'm still only like halfway through the Rust book. Might stream some of that. Or maybe I'll stream the thing that I actually wanted to learn Rust to do, which is the thing I'm working on. It's a game project. But anyway, following along LeetCode's list of problems. LeetCode. This is on LeetCode.io, but LeetCode is also like a YouTuber who's done a lot of like coding videos and talks a lot about these data structures, algorithms, questions. Anyway, we're warming up. We'll start with an easy. Already got this one open. Contains duplicates. Return true if any value appears at least twice in the array. Return false if every element is distinct. So I'm thinking we just make a set. We're given an array. We just make a set of the array and then compare the size of the set to the length of the array. Return new set of nums. Dot size is equal to, we'll do triple equals because I'm pretty sure those should actually be numbers. Hopefully. Frickin' JavaScript. Oh, I didn't set the timer. Okay, that was like, what, 5 seconds? Okay, whatever. Surely. Oh god. It begins. Oh wait, no. I think I reversed the true if any value appears at least twice, so that means that it doesn't equal. Okay, I just reversed it. Haha, very funny. Submit. All right. Always curious about like performance with these things. I know that languages like JavaScript or Python or even Godot, GDScript, like a lot of the stuff that you call gets run by like a C++ engine that's like faster than, if you were to write code in JavaScript, although I know there's also like some optimization steps that can happen. 07 Neo Hello Cyclocalist. Yeah. More JavaScript. Let's do a medium. You know, I probably should be doing some harder ones. All right. Group anagrams. Given an array of strings, group the anagrams together. You can return the answer in any order. An anagram is a word or phrase formed by blah, 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 blah. So we can find an anagram just by checking that the frequency of each character is the same. It's probably going to involve like a map. The map type in JavaScript. Don't need to specify it's a hash map. I mean, we could use objects. Like an object could actually be faster than the map in some cases, I've heard. But anyway, there's up to 10 to the 4 strings. So 4 zeros. Wait, oh god, I'm not getting stuck on, that's 10,000, right? Wait, 10 times 10 times 10 times 10 is 10,000. Okay. And then strings can be up to 100, and it only consists of lowercase English letters. There's probably some optimization you can do with like you know, converting the strings to numbers or like the characters to integers, and then doing some bit manipulation shenanigans. But I'm just not going to worry about that right now. Let's see. I do see single empty string. Okay, there's at least one string, so that's a case to do. We do have to consider the empty string. Ooh. Ooh. Let's bring up MS Paint. Let's bring up the Ms. Paint. What are we doing here? Let's see. Let's start with a simple example, like input is nat and tan. Oh god, my handwriting. All right. Lovely mouse handwriting. I see some YouTubers do like drawings in Paint and stuff, and like the you can kind of tell when they're using like a drawing tablet instead of the mouse. And it looks a lot nicer. But anyway, group the anagrams together. For each string, we're making like a frequency map, right? It's going to look like N1, A1, T1. They're going to get up to 10,000 strings. Can't just split the string and reverse the array in place. Wait, like sort? Oh, wait. Like sort each string? Or sort each... I guess you could. Wait. Split the string and reverse the array in place. Oh, string.split? Oh, yeah. String.split. So, like, yeah, like, no, it would need to be sorted though, right? I mean, that works for this example, but then, like, generally, let's say it's NTA. That would also be an anagram. So it would need to be sorted. So we could sort the string. Does JavaScript even have like a string sort? That seems weird. I mean, I guess you could like iterate over it. But yeah, a sorted string, you could compare by like string equality. String sort. Hold on. Opening a new window. Yeah, array.sort sorts the strings like in like lexical order, right? Yeah, convert them to strings. Okay. But like we want to sort the individual characters of the string, or yeah, we could split it and then sort it, right? String split. Okay, I need to look up the syntax for string split. Wait a minute. I'm looking at freaking documentation here. MDN for the win. Yep, I am looking at MDN. Okay. Here, JavaScript reference string. Split. Split on space, split on nothing. Okay, we do need to get a separator. So we pass in empty string as a separator. So yes, call string.split. Call string.split. That gives us n with pass empty string as the argument. That gives us an array nta. Whatever. And then we sort it. And then we compare array equality. Should I just open up the freaking browser console? Hold on. Var a, let a equal abc dot split on empty string. So now we have a dot sort, a is abc, let b equal bac dot split, empty string dot sort. A equals b is false because they're two separate array references. A triple equals b is also false because they're two separate array references. Is there an array like dot equals or something? A dot equals? No. Oh god, we don't seriously have to write our own array deep equality whatever, do we? I guess it's not that bad. It's like what? I guess in theory you could do like reduce or something, but you write a function like function array equals ab is return a dot length equals b dot length and something we calculate. A dot length does not equal b dot length, return false. What am I doing with these parentheses? Dot has. That seems pretty inefficient because it would probably be like searching the entire array. It would be length of the first array times the length of the second array. I think we just loop over for let I equal 0, I is less than a dot length, I plus plus. I feel really dumb writing an array equals function here. I really feel like there should be something in the standard library, or do you even call this standard library for fucking JavaScript? If a of I does not equal b of I, return false. Return true. Like this feels really inefficient. I really feel like there should be Some kind of array. Array. Let's see, there's find for each includes index of. Yeah, I could write it in a more functional way or something, but whatever, man. Whatever, man. Deuce right, reverse shift, slice sum. Nah, screw it. Screw it. We'll just go with array equals. That also seems kind of inefficient here, right? For the constraints again, 10,000 strings and then strings of length 100. If we're doing it once for every string, but then like if we're comparing every time, if we're making a map, it seems like one of those questions that probably has like a really elegant, simple solution, but nope. But we're doing something dumb. I mean, string split and then sort. Premature optimization moment, of course. What's that quote? It's the root of all evil or something. It's the root of all messing up. Anyway. We just need to group these by these character frequencies, which I guess we're doing by sorting sorting it. Should be faster than using like objects or maps, maybe, I don't know. Then what? We need some kind of data structure. It's gonna be like a map. A map of, I don't know, it could be the sorted character arrays. So like A, N, T. And then this is just an array of the strings, I guess. And then we do some kind of transformation to get this into the output format. It works. I guess it works. Although that depends on how map compares keys, doesn't it? MDN JavaScript map, alright. Key equality is based on same value 0 algorithm. Okay. They correspond to used by many built-in operations. Oh, okay, so we can't actually freaking split then sort then strict equality, because those are still going to be different arrays, I think, so the equality probably won't work there. No, I think they want some kind of more efficient thing involving like converting the characters to ints or something. Maybe. Maybe. This was it arrays and hashing? I know you're not supposed to like technically know the topics beforehand, but oh right, that's what we made the freaking array equals function for. I mean, yeah, I guess it works. But then we're not actually using a map. Then we're not like, we're like comparing it to our own. I guess we can just make an array of the sorted things. So what it would look like, this is actually just an array. Oh god, this is getting so messy, I feel. This becomes an array, and then this contains just what? Just this? Just the thing. Hello, the best bet is for 20k. How do doggo, sir? All right, I'm suffering. I'm suffering a little. I guess this isn't like a JavaScript thing necessarily, because I'm getting messed up on the algorithm part of it. But also like these thinking about types when in a language where the types aren't explicitly stated gets kind of annoying to deal with, but oh well. Typically using all the original letters exactly once. Stories of I contains of lowercase English letters. Okay, so there can be like duplicate letters that we have to account for. We probably wanted some kind of like hashing function, sort of, based on just the counts of characters. Again, I think the optimal solution involves like converting the characters into numbers or something. But if we just want to get this done, then like that's sort of what we're doing, right? We're like hashing these strings, right, using like a custom hash function that just takes into account the number of each character, and then grouping them up based on that hash. And you know, 26 lowercase English letters, 32 bits in an integer. I'm pretty sure well, no, that might not necessarily work because, like, you have duplicate letters and you need to account for that. So maybe something more complex is warranted. Okay, what are we doing here then? For each string, we can get a sorted array of characters. Oh, cool, you got hands. I do have hands. I have hands. I can reach out and grab the keyboard. I can reach out and grab my water bottle and make noise in front of the microphone. Care code time. We could, in theory. I'm not sure if it's necessarily going to be faster than just... I mean, it depends on how we write it. Than just like using characters directly if we're writing it this way. So you take a string, you call split with empty string. You get an array of characters. You call sort on the array of characters. You get a sorted array of characters. They cared enough about performance, they wouldn't have written it in JavaScript. True. I mean, you know, you can still optimize for performance in JavaScript. There's lots of funny weirdness, like not just that, but like on a more general level of like the algorithm you're using, which is what these questions are. They're data structure algorithms. You know, sometimes, you know, you just gotta use the language that the project is already written in, and you still care about performance, even though you're using frickin' JavaScript. From what I hear, like the V8 engine, the JavaScript runtimes, they can do a lot of crazy stuff to make it run faster, to make it run decently fast. But anyway, the algorithm, right? Take a string, you split it on empty string, you carry that. Fun is pretty cool. I haven't tried it. In fact, it's been a while since I've like touched or cared about web dev in a while. But yeah. I guess we just store things in an object, but then we're like looping over every object. No, wait, there's probably an optimization we can do beforehand, right? They use JavaScript core instead of V8. Interesting. What am I thinking? There's probably some kind of sorting that we can do to the input strings beforehand to help. Right? Okay. So like you get a thing of strings. But we need the original strings though. Because I think we're going to be doing too much looping over things otherwise. Well, I don't know, 100, like, what is the worst case here? $10,000 strings, each string can be up to 100 characters. Even if we're looping over. I don't know, worst case it could be like 10,000 squared. You're already 23 minutes in. Alright, yeah, I'm taking too much freaking time. For each string, we split it on empty string. We get an array, we sort the array. We put that into some kind of data structure. And then we... Right, okay. Now you have to commit to getting people. Oh, you want the opposite. You want me to spend more time thinking about performance. Okay, that's fair. I should at least think about like how complex this algorithm is going to be. Like worst case, we have a different anagram for each string. And then when we have to check this array, like we don't have a hashing function or whatever. And then we're just looping over this array, and then it's like strs.length squared and squared. Right. There ought to be a library for this. Yeah, just import the LeetCode solution 49 group anagrams and then call the group anagrams function. We don't need to do any coding. We'll just let people who write libraries do all the coding for us, and we just build glue. We just glue things together. That's what we do. That's what coding is. This is a silly variable name, but whatever. Stares at flavor site code. I don't know, that kind of is what, like, there's it's everything's so abstracted nowadays that you kind of, I guess you don't have to, but like it's the easiest thing to do is just to, you know, use code that other people have built. It's free, it's out there, it's for you to use. I had a teacher in university who said, like, yes, use libraries. That's what they're there for, right? Why would you maintain a complicated piece of code yourself when there's someone else who has, like, seriously focused on it for a long time? Like, I have mixed feelings about this subject because on the one hand, like yeah, it's great to be able to just import the library that someone else wrote and then just use the thing, and all you have to do is learn. You're still doing some learning, right? You still have to learn how to use their API that they've set up, right? And you probably don't want to, you know, write a whole HTTP server from scratch and all stuff like that. Well, I mean, as a learning exercise, then yeah, it can be useful, but on the other hand, you have the frickin' JavaScript ecosystem where one package that everyone relies on for something super dumb like is odd can change and break, or can get taken over by a malicious actor and break the entire internet. So it's, you know, it's okay. It has good things, it has bad things. Fun fact, is odd depends on is even. Perfect. I love that. That's great. No. Oh, JavaScript. Why JavaScript? Why is the entire internet built on this frickin' language? NPM. That we're doing. What is this anagram groups variable supposed to be? Okay, whatever. This is anagram groups. It's going to be an object. It's gonna have an array as the key. Wait, you can't do that in an object. That has to be a map. It's a new map. All right, it's a map. Except to check the key equality, we have to use the frickin' we have to use our own custom array equals function. So actually what we should be doing instead of a map is our own custom map, which is just a goddamn object or something. Doesn't sound too bad. No, we'll just do an array, actually. This will be an array of... Oh, God. You know what? We can store string indices. Here's the problem. We need a map. These arrays... You smell what the rock is cooking? Okay, we map these arrays as the keys, and then we need to store like a value for that. I mean, I guess we could just store two arrays and then this is like an array of keys and this is like an array of values. I guess that's just like what the hash map is under the hood. And then the values are arrays of strings. And that's actually, that's our output array? That's our output array, actually. So we have like a keys array and a values array. And we just store like indices or to check equality. Oh, okay. Somehow that makes me feel better, even though I don't think we've fixed the complexity, like runtime complexity of this in any way, but whatever. Okay. Do not use for in for an array. Use for of to loop over the values. Stir of stirs. Is stir a keyword? No, stir's not a keyword. What am I thinking? Okay. Const store to stir array is stir dot split empty string dot sort. Wait, does sort return a reference to the array? It better. At least I have the console right here. Let a equal abc dot split dot sort. Okay, it does. Okay, it does. It does. Okay, for const key of if array equals key array sorted stir array we need an I, actually, hold on, for let I equal 0, I is less than keys array dot length I plus plus keys array of I. Some ugly code. Type so fast. Yeah, I haven't. Should I open up monkey type just to? Yeah, I can take a monkey type break after this question. After this problem, I get this feeling that our algorithm is too slow for the problem, but I'm gonna implement it anyway. If I take more than 45 minutes, I'm just gonna look at other people's solutions, because that is a faster way to learn this stuff. And I'm kind of distracted talking to chat. Okay. Keys array of I, then you know, when we insert into keys array, then we'll insert an empty array into a values array. So then there should be an array at values array of I dot push the stir. And then we actually want to continue to this for loop, but I guess it's okay. That means we'll need another flag to... that's annoying. Break would break this inner for loop, right? So if not inserted, God, we're adding all this extra state. Then, all right. Keys array dot push. The sorted stir array. And values array dot push. It'll be an array containing just this string. And then we return values array. These can actually be const even though we're calling push, but I'll just leave it as let to let people know that we're modifying these arrays. Because technically const just means that the array reference doesn't change, like this variable name reference doesn't change. Is that everything? This break, yeah, corresponds to this for loop. If we didn't insert, then yeah. Madden NFL 2001. Huh. Alright. Let's just run this. I feel like there's gotta be something I missed, but okay, I guess that worked. Now the real test is this fast enough? So we'll see when we submit and get a time limit exceed. Oh. Wow, we beat 5% of users! We're so efficient. Okay, I do actually want to see like what the more efficient solution is. C++, Java, Python. I guess we can look at the Python one. Like the algorithm is going to be what we're concerned about. Hide paint. All right. Group words, initialize variables, a map, no unordered map. Sort the word. Wait, just turn it back into a string and use the string as a key for the hash map. Then we don't have to loop over the entire freaking keys array. Oh my god, look at this beautiful Python super short solution. Anagram map, default dict list for word and stirs, sorted word, empty string dot join sorted. Yeah, that's what I was missing. Turning it back into the string would have made it way faster. Yeah, this shouldn't have been that complicated. But yeah. You know what? As an exercise, let's just try and write it the more efficient way. Then we don't need a map, but what we do need is like turn it back into the thing, which we can just call values. Okay, hold on. So let's see. This name is whatever. Call it anagram map. So, and we're returning anagram map dot. Does values return an array, or is it returns a new map iterator object? So it would be array dot from anagram map dot values. Pretty sure. Sorted string. Stir.split.sort, and then we need to turn this array of characters back into a string. In Python you have join. In JavaScript, what do you have? Here I go, looking up syntax again. .toString. does that work? Hold on. Array dot toString. I see comma separators, but if it's like, hold on, let A equal A, B, C, A dot toString. No arguments? No, I guess you can't. On sparse arrays, on non-array objects. There's gotta be like a string constructor from an array. String constructor? I guess it would just call toString, right? String.toString returns the string value. Right, not a string object, but a string primitive. I guess you could do an array reduce. I guess you could do an array reduce. Right. Accumulator, current value, initial value. That sort dot reduce. Initial value is empty string. And we can just return ACK plus the current character. And that's the shortest string. Should be. Anagram map of... Can we pass like a constructor to map like in Python? I imagine not. not array prototype map. Map iterable, yeah, okay. Right, you can do map dot set with map dot get. Because get can, oh. You could use the null coalescing operator, I guess. Dot set. Hold on. Syntax. Set key value, of course. Hopefully, that's what I would hope it is. Key is sorted string. Value is anagram map dot get of sorted string dot question mark dot push the original string. And if that doesn't find anything, then return array of string. Right? Let's see. Push is not a function. You're telling me that's not an array? Hold on. Get sorted string. Array string. We were so close. This might be trying to be too clever. We'll just do if anagram map dot has sorted string, and anagram map dot get sorted string. Oh wait, is it the push? What does push return? Hold on. Returns the new God. Returns the new length of the array, of course. Okay, all right, fine. All right. If it has, then we push the string onto the existing array. Otherwise, anagram map dot set sorted string array of string. I keep forgetting my semicolons. I'm too used to GD script or Python or something. This works, right? This better work. Yeah, okay. That makes me feel better. That makes me feel better than the last solution. Wow, guys, we beat 97.95% of users. Had to look at the solution. Anyway. Semis are not actually required in JS as long as you have a new line. Here's the thing I heard about that. Was it JavaScript, automatic, semicolon, insertion. It's not cheating, it's using all available resources. True. Here we go. Automatic semicolon insertion. Some JavaScript statement syntax definitions require semicolons. Okay, however, to make the language more approachable and convenient, JavaScript able to automatically insert semicolons. Yeah, like, okay, most cases it'll probably won't mess things up, but sometimes there's like a few specific cases where that'll mess things up. I forget exactly what the examples were. Yeah, that makes sense. Yeah, that makes sense. Preferences can be seen as a function call. It would usually not trigger ASI. Ah, here's the... Wait, no. Yeah, here's the example where we're not putting the semicolon and mess you up. Then it tries to call the function. It calls a function with an argument of. It calls the function 1. It calls 1 as a function because of this weirdness. And here it's, what the hell is this? Property accessor with a comma joined expression. What? Evaluates each of its operands, returns the value of the last operand. Commonly used to... I have never... JavaScript, why? I've never seen this before. To join assignments. Yeah, okay, I would expect this. Right? C equals 4, evaluates... Wait. Its result becomes the return value. Oh, okay, so of the entire comma expression. So, like, this whole thing... This whole statement evaluates to 4. Okay. Okay. Okay, that's... Okay, I guess. But then you get, like, this. So, like, this would return 3 as the value, and then it would be evaluated as trying to access the... Yeah, the property 3 on 1. Class fields and generator methods can be a pitfall. Yeah. Okay. So yeah, there's some cases. Generally, you won't run into them, maybe, but I wouldn't wanna. I wouldn't want to risk it. Do people actually use generator functions? I feel like I've seen them more in Python, but maybe just in like Python examples. I'm not... I don't think I've seen any like serious uses of generators except for... I want to say I've seen it in Python before in like some examples. Although that might have just been like in the context of learning about generator functions. So they probably are used, but probably not commonly. Maybe in like if you're designing a library or something that might use that. I don't know. Or are JavaScript generators used? Generator object returned by a generator function. Yeah, I'm more familiar with Python generators, but that's probably just because I was learning about generators in Python specifically. Generators can yield multiple values, work great with iterables. Yeah, that's one use case I know about. Generator.next, generator.next. Never even heard of it until I needed to recursively walk a door. Yeah, something like, yeah, something lower level than what you're usually doing with a language like JavaScript. There's probably some uses, but I've never actually used it myself, I think. So monkeytype.com, yeah. 30, 60. I know the leaderboards are on 15 and 60, I think. One 42. Flexing your WPM. Okay, yeah, I'm pretty much just flexing. Crazy finger stamina, thank you. It's because you mentioned the high typing speed, so I had to. Okay. All right. I'm gonna be right back, and then I'll do some more LeetCode, of course. All right. Hello. Hello. Okay, yeah, that's enough flexing. Come on. We're here for data structures and algorithms. We're here to talk about JavaScript. We're here to... It's a janky language, but it's our janky language. I was reading the comments. I watch a lot of Primogen's YouTube videos. Well, they're just like stream clips, but someone in the comments of one of them was talking about how much fun he seems to be having with you know, even when he's like reacting to an article about like how jank JavaScript is. But instead of like complaining about it or like talking about how, oh, JavaScript's such a terrible language, that he's, you know, he has fun with it, and he, like, you know, has its good points, it has its bad points. suddenly communist. What are we doing? Gotta appreciate the jank. Yeah, and it got me thinking about like mindset. Like you can look at JavaScript, see all this weird stuff, and be like, ugh, this language sucks. I hate it. Everything sucks. This is awful. I want to die because my fucking expected something and I got undefined, and then the entire app just broke silently. Or, you know, you can just accept the jank, be one of the jank. It's free job security though. Have fun with it. Yeah. Turn the K most frequent elements. Ooh, okay. Okay, we return we get the counts, and then we sort the... Okay, we make a map. The map contains frequencies. So it's like a map of number to count. We get the entries from the map. We sort the entries by the frequency, and then we return the first K elements of the keys array of that map. It's been a long time. Yeah, speaking of job security, there's been a lot of layoffs in the tech world in the US, and well, I don't know, it's got me rethinking how easy it is to be in this field in programming as a professional. Went out for a bit. Are you winning, Neo? We're back to JavaScripting. We're back to LeetCoding. All right, I was reading the thing and coming up with the solution while the timer was going, but oh well. What did I say? I should open up Paint anyway, even though. Make a map. It's gonna have keys values to frequencies. So like 1 to 3, 2 to 2, 3 to 1. Get the entries, and then sort by keys, or sort by values, which are frequencies, and then return the first K keys, which are the numbers. Use SO links in production for maximum job security. Based. It's a great idea. Yeah, I'm writing my next startup in brainfuck. You don't need not to flex or anything, you know. Yeah. All right. I guess we can use map. What's nums length 10 to the 5th? Yeah, that's probably enough to warrant using a map. Let cool new map. Frequency map is a new map. Python has like a counter like dictionary class that is extremely convenient because it literally does this stuff for you. It does this thing for you, but for let num of nums freq map dot. Pretty sure there's also like some easy stuff to make like counting stuff easier, but yeah, but if frick map dot has num, if you call get and then plus equals, does that actually increase the value? I'm just gonna be safe and do like freak map dot set freak map dot get of num plus 1. Else freak map dot set num. Oh wait, need the key and the value. The key is the num, the value is the frequency. Right, so that would have been a one-liner in Python because we just use counter. Forgot my semicolons. We get the entries. Return the k most frequent elements, returns a number array. We could do array.from array slice. Right? Yeah. Okay. Const. Do. Love this track from Mario 64. I remember seeing those videos about, oh, if you wait for an hour on the race results screen, then there's a second version of this song that plays. It's like a secret. Sorted frequencies is map.entries.sort. So we have key 1 value 1, key 2 value 2. Those are our arguments, right? And we're sorting by value, descending, which I think means it's v2 minus v1. My boy be coding. We're coding. That better be right. I hope that's right. The entries are key value, sorted frequencies. Yeah. I guess we can use a for loop that's simpler, less thinking. For let I equals 0, I is less than k, I plus plus. At least less thinking for me. Const result equal array. I mean, we're modifying the array, so maybe do that. Result.push sorted frequencies descending of I of we're getting the key, which is index 0. The key is the number, yeah, the element. Let's see what I forgot this time. Let's hope. Or don't hope, just trust. Okay. Entries dot, okay, array dot from. Because this is probably an iterator or something. Okay. Okay. It's okay. It's something. It works. Let's keep going. How Sudoku 2 pointers. 2-sum 2, 3-sum. 3-sum. Yeah, that's like the harder version of 2-sum. Should we do all 3 2-sums? We'll do 2-sum 1, 2, and 3. I know there's like some funny stuff involved in this. I mean, I've done this a number of times. Like, it's been a while, but I have done this in a while. And you just use a map. 3-sum. Your message got held for review. Yeah, it's like twosome, but one more. Haha. I mean, it's probably good to do stuff that I haven't seen before for practice. Should I just not do? Maybe let's preview threesome and see what it is. Return all triplets. I, J, K. I is not J. I is not K. J is not K. Nums I plus J plus K equals 0. That's interesting. Okay. So the trick to twosome is that you just make an array and then you like store the difference between, was it the number and the target? In this case, you're just adding to 0. How long is the array? 3000. So this could be like a pretty complex algorithm. What's the naive way to do this, right? I still have Paint open. Something like I, J, K. And then loop K, K, K. And then increase J. And then increase J and loop over K, and then, yeah, it would be a triple for loop, right? And that just checks every triplet. Solution set must not contain duplicate triplets. But what if the array contains... Okay. Just checking the algorithmic complexity. 3000 cubed is 27 billion. That seems reasonable for a problem like this. Oh well, alright, whatever. Let results equal is an array, returns a number array of arrays, alright. Or array of number arrays. Number array array. Array array array. Let I equal 4, let I equal 0, I is less than num's length, I plus plus, 4, let j equal 0, j is I plus 1, j is less than num's length, j plus plus, 4, let k equal j plus 1, k is less than num's length, k plus plus, so the triple nested for loop. This is just brute force. Like, we aren't told that they're sorted or anything, so I guess there isn't an optimization. We could sort it ourselves, actually. We could sort it ourselves. So there's probably like an optimization in there. Oh well. We'll just write this naive solution and see if it beats the time limit. Oh, didn't start the timer. Nums I plus nums j plus nums of k. We'll do triple equals, just so nothing funny happens. returns nums I, nums j, nums k. Results.push, nums I, nums j, nums k. And then we just return results. That seems too simple. Makes me very concerned. I feel like the goal of this exercise is not to write the naive solution, but to think of a more efficient one. But let's see. Oh, we actually messed up something. Oh, because these do count as duplicate. Right, okay, so they do mean if the numbers are the same, then that's a duplicate. So don't include it. The order of the output, the order of triplets do not matter. Distinct triplets. Yeah. IJK, how long is the array? 3000. I'm thinking it involves a map of some kind. Hash map as always. What kind of map? What kind of map? We need like nums I, nums j. So it has to be based on the numbers. And that's like the key in the map. Or we could use a set. We probably want to turn these arrays into a string or something. I guess a string is fine to... I guess a string is fine. What would that look like? So like function num hash num1, num2, num3. I guess we could take in an array of numbers, right? It's just that we're always using 3 numbers. What does this look like? Do we make a string? I mean, it's probably making a string. Wait, it's literally just sort the sort the array and then call toString. Sort A, B, don't forget this. A minus B. toString. Right. Because I'll return like 1, 2, 3 like array, like it'll look like this. It'll look like this. And then we can use that as a hash. Array nums I, nums j, nums k. Yeah, we'll just do let numster equal numhash. And you know, we'll use some more variable names to clean up this code. Yeah, numsum, numster is numhash, numarray, nums I. Yeah, I can copy this. If numsum is 0 and let scene equal set, new set. Not scene dot, is it has? I'm gonna assume it's has. Numster. Scene dot set numster. Or is it add? Is it add? Actually, you wrote down like a cheat sheet. Set. Set. We have add and we have has. Okay. Add and has. Yeah. Alright. Alrighty then. Alrighty then. Still feels slow. Still feels like it's gonna be slow. Yeah. We got callback hell, for loop hell just dropped. There we go, time limit exceeded. Of course. Of course. Of course. Do we look at the hint yet? I mean, we've spent less than 10 minutes on this. 2 pointers. 2 pointers. And sorting. And sorting. Yeah, I had a feeling it involves sorting the array. Alright, let's bring up good old MS Paint. Got an array. Whoops, brush. You have an array. We'll say it's sorted. We'll say it's -1, 0, 1, but you probably need a more complex one to... Let's just copy the example. So this array sorted, the example array sorted would be -4, -1, -1, 0, 1, 2. It's probably gonna start at the center and do some kind of, it's gonna middle out. It's gonna middle out, guys. But anyway, normal to some, or like some of the whatever two pointer, with a lot of these like 2-pointer problems, you're like below a target, so then you increase one value or something like that. But seems a bit tricky to manage 3 pointers at once here. Yep, love those triply nested for loops. Maybe let's look at the 2-pointer case, right? So 2 pointers. Oh, this is too low. This adds to -5. Just gonna move 1 pointer, or we can move the other pointer. It's like this would move all the way to here, and then it's still below. So then call this j. So then I would move to here. It's still low, or now it's too high actually, so then j would move back to here. And then it equals 0. And then either I or j would move. Now when we add 3, now when we add a third pointer. How should we visualize this? I, J, K. Should probably be, the arrow should probably be above. I, J, K. Solution set must not contain duplicate triplets. Yeah. I is not J, J is not K, I is not K. So what do we know? Like, we have the sum of this whole thing, which is -6, which is less than our target, 0. So we need to move either J or K, but how do you make that decision? And how do we, like, cover all the possibilities here? Let's see, K. I mean, we could move K. Let's just say we move K. Then it goes to 0. Then our sum is -5. Then we move K again. Sum becomes -4. Move K again. Sum becomes -3. And then we start moving J. Have we even... Do we use the fact that like J and K, I, J, and K are less than the target as a heuristic? But how do we cover every case in that case? It's like I is at the beginning, J is somewhere in the middle, K is at the end. I don't know how this generalizes. How does this generalize to every case? I'll spend some time thinking about it. Or maybe I'm looking at the wrong place. Maybe my num hash is the actual thing preventing me from getting a faster solution. Or like getting a solution fast enough to be accepted. No, there's got to be... I mean, they specified 2-pointer, so it's got to be some kind of optimization involving that. That and sorting the array. Okay, fellas. Okay, fellas. Sort the array. Sort the array. See, I understand 2-pointers, but when you add the third pointer, what if it's just like a 2-pointer, but then we add in a third pointer? It's like the wild card. Ooh. Then how does that work? When you're doing 2-pointer, right? You start here, and then you can... You know what? Let's do two, not two-sum, but sorted two-sum. Let's do sorted two-sum. Let's do sorted twosome in order to warm up towards this in JavaScript. Given a one indexed array of integers numbers sorted in non-decreasing order, find two numbers. Just say add to a specific target, return the indices. There is exactly one solution. Ooh. This is slightly different. Only constant extra space. So probably in place. Just like loop over the, check the array of 2 pointers. 2 pointers. Two pointers. Two is less than numbers that length is less than or equal to 3 times 10 to the 4. There's only one solution. May not use the same element twice. Constant extra space. Okay. Do you even need to? Exactly one solution. With that length, 3 times like 30,000? I guess those parts aren't actually like technically part of the question, but like you can always kind of guess the level of algorithm complexity they're expecting based on those. It's already sorted. Let's just draw this out. Maybe not the first example, maybe 2, 3, 4. Right. I, J, target 6. 2 plus 3 is 5, is less than 6. So we need to move either I or J. We'll move J higher. Then return the indices of the 2 numbers. Move J higher and then we're done. Wow. Okay, but what about more generally? Like we're gonna have to move I at some point, right? So what's an example that forces us to move I? So like T. We don't have to start at the beginning of the array. Oh, the music. Do 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 do. Something like 1, 2, 3, 4. Target 6. So what would you do here? What do I do? Okay. I plus j is 3. 3 is less than 6. So can't move I. So I guess we move J. Actually, you know what? Let's make the example 5 so that we have to move I in this example. Bum, 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 bum. Man, this menu screen. So iconic. Pulling on Mario's face in the Super Mario 64 menu screen. Alright. So here... Actually, no, this isn't the example I want, because you don't need to move I in this case. Actually, do you ever need to... Hold on. Okay, let's do target 5, but then this number's like... Whoops. That OST's a banger, yeah. Alright, this number's 11, so now we're being funny with it. Target's 4, which is less than... which is less than our target. So let's say our algorithm moves J again. Now our sum is 12, and we're above the target. So what do we do here? If we move J back, we already checked I here and J here. So I think we move J back and also move I forwards. So if we ever exceed the target, then we move J back and we move I forwards. Okay. Move I forwards. And then move J backwards. And now what if we're still below the target, then... Then when we move J forwards, then we move I... Then it's too big, so we move J backwards and move I forwards, and then I and J are colliding. Do we just end in that case? Do we just end in that case? Like, are we sure that there's not going to be any other solution in that case? If I touches J. Because the array is sorted. I'm pretty sure that in that case, like, we move J forwards. Let's say the target was 6. Then we move J forwards. And then we move J backwards and I forwards. And then we just end. Because yeah. I and J can't be the same. I think that's right. Guess we can just try it. How long have we been on this? Well, we started this 2sum2. We might need to look at the hints on 3sum. It's not it probably isn't actually useful, that useful to study this one, because it probably doesn't generalize to other types of problems as well. Maybe more complicated problems. The other interesting part, it's one indexed. So return the indices of the two numbers, index 1 and index 2, added by 1 as an integer array. Oh, so the actual array is that gets passed is 0 indexed, but then they want to return the indices as 1 indexed? Is that what they mean? Hold on. Like, that gets passed to me as like a normal array in the language that we're using, right? Is that even relevant? Like, do we just add by 1 at the end? Or, okay, whatever. Well, we're gonna have an I, j equal 1. And then if we find the solution, return, well, there is exactly one solution. We are going to return, oh right, that's another thing. The test, there is exactly one solution. There is exactly one solution, so then we don't have the case where, like, I crashes into J. Right? Integer array I plus 1, J plus 1. I'm gonna assume that's what I mean. While numbers of I plus numbers of J does not equal target. Numbers of I plus numbers of J if sum less than target. Parentheses. If we're less than the target, then are we still looping over every possibility here? Well, no, I guess not. J plus equals 1. Continue, or I'll do like an else if sum is greater than target. J minus equals 1, I plus equals 1. And we're guaranteed a solution according to the problem description, so I think that's always gonna find something. If there isn't, it'll crash or something. Or get stuck in a loop or something. Okay. Did find the solution for the given cases. Time limit exceeded. Oh wait, then J goes out of bounds. If what am I doing? J going out of bounds. Sum is greater than target, or we'll move this check up. If the sum is greater than target, or J is actually we do need some bounds length or bounds check on J. I'm not sure if it goes in here. Don't think it goes in here. I think we can just do something like this. If J is J plus 1 is less than numbers dot length. then increment j, else increment I. This seems funky. Seems a little funky. What was it? 5, 25, 75, target 100. Yeah, I just want to check that case. Well, it works. I feel like we're getting stuck in an infinite loop here. Is it better to just naively go about this? Use a for loop. Like, given the number of numbers that we're given, I think the n squared approach might be easier for let I equal 0, I is less than number's length, I plus plus. For let j equal 0, j is less than... But that defeats the point of it being sorted, right? Seems wrong. It seems pretty wrong. The point of it being sorted is that you can find something, find a faster algorithm, right? We could do like n log n, do like a binary search. Like, okay, so for each I, you do a binary search for target minus numbers of I. I think that sounds right, I guess. I think Python has like might have a binary search in like the standard library for like arrays. Pretty sure JavaScript wouldn't. And then j can't be I. But there could be dupes. But I think we can disregard anything before I, so actually it's a binary search of the array from the part after I. No hits. I'll look at the topics. Binary search. Yeah, it's a binary search. Of course. Been a while since I've implemented binary search. Okay, binary search. If we're less than the value, then we look at the half of the array. Okay, we find the middle index of the array that we're searching, right? What is binary search? You find the middle index of the array you're searching. If we're less than the target, then we continue searching with the half of the array that is greater than the index we just searched. And if we're less than the target, no, if we're Okay, assuming it's sorted ascending, right? Let me bring out the MS Paint. 1, 3, 5, 7, 9. Okay, we're looking for index, or we're looking for 7, right? We'll say we look at 7. We look at the middle index. Length. That'd be index 0, 1, 2. It's, yeah, floor of length divide by 2. Yeah, or like integer divide. I guess in JavaScript you have to do floor. We look at that middle index. We look at the value there. If we're 5 is less than 7, so we disregard this half of the array and we continue searching here. Length is 2. I guess that would go here if we did it like that. If you did length over 2. 9 is greater than 7. So then we disregard this part of the array and then we do this. And then we find the value. Or not. If we don't find the value, then we didn't find the value. Too bad. Too bad. It's been like a million years since I've implemented or looked at a binary search, so this is for studying, right? So like realistically I should probably just look at a binary search implementation, but it'll probably stick in my head better if I actually try to implement it. If I try to implement it, fail, and then look up the answer, then it'll stick in my head better. Oh, I'm running out of water. Might need to end stream in a bit. Just cause my brain hurty. Actually, if we bring that to 3-sum, it's probably involving a binary search, right? You sort it. Then for each I and j, then you do like a binary search for the target k. That'll probably get you there. Yeah, that's probably it, isn't it? What do we need? We need a start index. We need an end index. That's all we need, right? And we need a target, of course. And if we don't find it, you can return nan or null or undefined, because JavaScript is a funny language. If we don't find it, okay, first is start and end inclusive, exclusive. Start inclusive, end exclusive, I think is usually how these go. Then you calculate the length, right? So if start is greater than or equal to end, we'll do null, I guess. Middle index is start plus end over 2, right? But floor. How do you do this in JavaScript? In other languages, you would just rely on integer division. In JavaScript, it's like math.floor. Probably. Math.floor, yeah. Is this just start plus end? Because at 0, end is the length of the array, then divide by 2. Start plus end, divide by 2. And I could do the while loop. I could do the while loop. Probably should do the while loop. While start is greater than less than end. And then return null. Let middle index equal map.floor, start plus end, divided by 2. If array of middle index is less than the target, or less than the target, start equals middle index plus 1, continue. If array of middle index is greater than target, end equals middle index, continue. And then the last case, array of middle index is target, triple equals. So I don't trust type coercion. Then we return the index, right? Yeah, I think that's what we want. That's binary search, right? Right. Okay. For let I is 0, I is less than number's length. Okay, for each I, let cur target const cur target is target minus numbers of I. Cur j. We'll just get rid of this. J equal binary search of numbers from start to end to target. So start is I plus 1. End is numbers length. Target is cur target. If j is not null, I'm pretty sure that's how you check for null here. Then we have a result. So I plus 1, j plus 1. Pretty sure that's it, right? As long as my binary search is correct. Right. Ah, there we go. I remembered binary search. I haven't forgotten my entire computer science education. I need to get some water. I'm gonna be right back. Ah. There we go. Hello, chat. Pachi arigato. Thank you, Psych Locust. Now that we've done that, I guess we can move on to threesome. Which is gonna be... I'm pretty sure it's just... like... yeah. Get rid of this inner for loop, the K for loop. So let K equal J plus 1. Wait, no, we want to do a binary search. Oh, we did write the binary search, right? So there we go. Start inclusive, end exclusive. Yep, as per usual. Binary search of nums with a start of j plus 1 and an end of nums length and a target of it's -1 times nums of I plus nums of j, right? Whatever will make it 0, right? That would make it 0. So if K is not null, or if K is null, then we'll just continue. There could be multiple triplets. Ah, god damn it. There could be multiple Ks. There could be multiple Ks here. That give you the solution. Oh, hold on. Oh no. Oh no. Oh no, I don't think this is gonna I don't think this is gonna work. Because there could be multiple Ks. Also, first we need to sort the array, so nums dot sort A, B, A minus B. Yeah, make sure it's sorted. But now if there are multiple Ks, then they'll all be together, right? And also, the solution set must not contain duplicate triplets, so that actually already covers us. Because all the multiple Ks would be the same value. Okay, so this does work. Otherwise, num sum should equal 0. This should equal 0. Alright, so we don't actually need to check. Yeah, don't need to check that. Could still be dupes, so I'm pretty sure we still need the scene set. Well, let's see it. Let's run it. Let's see if I messed up this target value. Accepted. Okay. How's the time complexity though? Let's see Paul Allen's time complexity. Time limit exceeded. Okay. I have a feeling it's that freaking numHash function. This is ugly as hell. Distinct triplets, nums0, nums3, nums4. Not Paul Allen's code. God. What's the actual... Okay, there's gotta be a less dumb way of doing this. Num sort toString, right? But how else are we gonna, check that we're not adding duplicates? Wait, can we just... No, we can't just get rid of the duplicates from nums. We can't just filter out the duplicates from nums. Because we need to know how many of each number there are so that we can do something. Anyway, I'm pretty sure it's got to be this nums hash. Num hash is slowing things down too much. Hints? We fixed one. Yeah. Two sum. Yep. Two sum. Yep. Binary search. How do we hash the? How do we check that we're not adding duplicates? Add The order of the output and the order of triplets. This is annoying me. It's such a... It feels like the details. Hmm. Or creating an array, like that's probably also adding to the... Yeah, creating an array, calling sort on it, turning it into a string. It's a lot of shit to do for 3 numbers that we already have just the numbers for. Like what actually makes these numbers unique? I mean, we know that they sum to 0, so like the sum isn't really going to help us, but because this will find duplicate triplets. Or will it? When it's sorted, will we actually? Will it? When it's sorted? Hold on. MS Paint. -1, 0, 1, 2, -1, whatever. I'm already writing this. Okay, sorted. -4, -1, -1, 0, 1, 2. And the duplicate ones that add 0 are... Yeah, it's -101 and -101. IJK. And that isn't necessarily on I, it could be on J. Could be on K. But if we've seen I and J before, if we've seen I and J before, then even if we find K, we know it's going to be a duplicate. So I guess I could speed it up by only using I and J in the hash. That is an optimization, technically. I just want to know. I just want to know what the... if I were doing this in Python, what would I do? I think you... Can you have complicated keys and stuff like that? Or like, does the... You can store arrays in a set? We don't need to sort it because we already know that it's sorted. because the array sorted and I is less than j. So it's just nums.toString. And then we can get rid of the indirect function call. This feels so dumb. That actually was accepted. I actually fucking... Oh no. Yeah, adding that extra function call, yeah, slowed things down. Okay, how are we actually supposed to fucking remove the duplicates? Let's see what other people do. Two-pointer solution in JavaScript. Doesn't matter as long as it works well. Not if you're trying to get hired. God. Oh no. Find the target triplet. Does this even use the binary search or what? What did you do? While j is less than k. Result push. Oh, you don't even need to check for duplicates. Time complexity n squared space O of n. Python storing uses Tim squared, which is O of n space. Okay, what's this? Fix I at index 0. J starts from I plus 1. K starts from the last index. You decide and move J or K. Start the input array. Then you decide which index to move. J to the next. Speed up. J moves next. J moves next. J and K are same index, stop iteration. We have to find all triplets. Fix I. With next number same as current number. Okay, we found -1, -1, 2 again. Target triplet, but description says no duplicates. To avoid this, when you found one of the target triplets, we move J once, but we check the number after we move J. If the number is the same as previous number, we continue to move J until we find a different number so we can avoid duplicate combination. Right. So yeah, a while loop somewhere. Or if I is greater than 0 and nums of I is triple equals nums of I minus 1. Oh. Oh. You just need to check I there? Huh. Okay. Okay, I think we should keep moving. We've got more stuff. Sliding window. I feel like I'm pretty familiar with linked list. Binary search. We did a binary search one. Heap priority queue, backtracking, trees, TRIEs, graphs, dynamic programming, greedy algorithms. Those can be hard. Math and geometry. Forget which of these I've done before. We'll just do a random medium. Remove the nth node from the end of list and return its head. Could you do this in one pass? Is it medium? Am I missing something, or is this like relatively simple for a medium? One, 2, 3, 4, 5. N is 2 nth node. Oh, that's the tricky part. Nth node from the end of the list. So this would be the first. This would be the second from the end. And how long is the 30? 30 nodes? Oh wait, I'm not showing my Mammoth Paint. Here. Beautiful diagram. What the... And it's a singly linked list. Usually, I'm pretty sure you can like cheese this by turning the singly linked list into like a doubly linked list in a dynamic language like JavaScript. Are you fully self-taught? No, I went to university for this. Sometimes I wish. Well, I don't know. It's tricky, right? If your goal, I think if your goal is to get hired, then, you know, going to college, making connections, talking to people, and then also having the degree on your resume helps out a lot. I didn't do a ton of networking though, and I'm kind of feel like I messed up by not doing that as much, and like talking to other people and meeting people. Uni gets the degree, but like you learn shit mostly on your own from my experience. Yeah. It's pretty true, yeah. Like, I took one class on web dev before I got my first web dev job. And like, I had not like touched web dev before that, really. Just a little bit. I'd messed around with like HTML, CSS, JavaScript a little bit before that class. But, you know, we touched on React in that class, but I had to learn some other stuff. More libraries, more frameworks, more languages. Anyway. I feel like I've probably done this one before at one point, but I've forgotten the solution because it was a while ago. See, I always hear about like about people who say that like their company has a self-taught programmer and they're really good. But I feel like that's because to get hired as a self-taught programmer in the first place, you have to be really good, right? You have to have like a really impressive portfolio or something, right? I mean, that's just stuff I hear online. Yeah, have to have a bunch of your own things already. Pretty much. You can like barely pay attention to all your classes and not really do any impressive side projects or anything and still get the degree, and well, that doesn't necessarily mean you're hireable at that point. It's possible, which is cool since other fields you can't, but it's still a lot of work. Yeah, you gotta learn. You gotta make shit. Yeah, and if you have the ability to do that, then yeah, you save on, you know, the expense of college. So that's pretty cool. I'm just not sure if I give enough of a shit about web dev to keep doing it, which is why in my free time I've been like working on learning game dev. Video games. Learning Rust. Learning Rust right at the moment right now. Maybe I'll stream some of that. Would be cool. Yeah. Yeah, Rust is pretty cool. It's a pretty unique language. Got some interesting stuff. Actually, the reason I started learning Rust was because I was trying to do like a high performance part of the game that I'm making in Godot in C++, and I got totally skill issued because I took like one class on C++ in university. It was like the hardest class I ever took, and after that I was like, no, I don't want to touch C++ again. And then I come back to Godot and I'm like, oh, I have this thing in my game and I want to have like thousands of enemies being processed at once, and I really want this to be performant, so maybe I'll try out some multi-threaded C++ and use this ND component system library. And I tried to do things and it was really hard and my program kept crashing and I had no idea what the hell was going on in the memory. So that's why I'm learning Rust. There's a game engine called Bevy, and also has an entity component system, like high performance, multi-threaded, all that stuff. Making game what kind? It's Vampire Survivors, but first-person shooter. The short pitch is like Ultra Kill meets Vampire Survivors, but it's still got a long ways to go to to sort of live up to either of those titles. But yeah, I like boomer shooters, and I've also been like addicted to those Vampire Survivors, Bullet Heaven, whatever you want to call them, games. So wanted to give my own take on it and take the parts that I love about FPS and put it in a game like that. Sounds dope. Thank you. Yeah. Yeah, if I get it to a state where I'm happy to show it off, then yeah, I'll probably show it off on this channel actually. But until then, I might do some development on stream. Maybe. I'm still thinking about it. But I'm totally willing to learn Rust on stream. Nice idea. Thank you. Alright, let's get back to linked lists. Remove the nth node from the end of a list and return its head. Can we just, you know, allocate extra space and store references to each list node? Could you do this in one pass? Yeah, right, because the naive solution would be like n squared. Or like you do one pass to find the length of your linked list. And then you do another pass to remove the nth node. Yeah, because you don't have the length of the linked list. That's the real problem. So yeah, two pass don't need to allocate any extra space. And then one pass, you would you could just make an array or something, and then store references to each node. And then once you find the length of the array, or like the length of the linked list, then you go back to the nth node to remove it, or, well, the n-1 node. Or the n+1th node from the end, since that's actually the format that they give it in. Okay, so I do remember this problem. I'm pretty sure I did, like, yeah, either one of those. Anyway, it's kind of silly though, right? You're storing you make a list of references to this entire linked list. You're like making a whole other structure. But oh well. All right, to do this in one pass, event space. List array is an array. Let cur equal head while cur dot next. It's kind of one pass, right? Well, yeah, you do have to loop through the entire array or linked list to find the length. List array. Actually, yeah, while cur, not cur dot next. List array dot push cur. So yeah, that's pushing a. I hope that's a reference to the. I hope that's a reference. I hope that's a reference to the list node, and not copying the entire value. But shouldn't matter either way. Cur equals cur dot next. Now we can get the length and then find the index. So index to remove is list array dot length. Length minus n? Yeah. Set up to, because if it's 1, then it's, yeah, the last index. Then list array of index to remove -1, so the previous one, dot, that's a list node, so dot next is list array of index to remove dot next. Don't do index to remove +1 because that could be the last one. And then we can return head because we've been modifying the actual linked list, right? Right. Right. Oh god. Setting next? Wait. Then list array of index to remove -1. Oh, it's this case. Oh, it's this case, of course. Head is 1. If list array length is greater than 1, else you return null. Is it null? Else we're removing the, oh, we're removing the head here. Oh, right. Okay, so this case we're removing the head. Return head.next. This could also be index to remove is greater than 0. Right. Yeah, I've got to check those edge cases. Gotta check the edge cases. Damn it. I feel like I should be looking for questions I haven't already done before. Might have done some of these on the last LeetCode stream. It's been a bit. Trees, heap priority queue. Does JavaScript have a heap? Like the heap data structure? Heap.js. Oh no. Heaps in JavaScript. How to represent a heap. Pairing the, yep, implement it yourself. Great. I would not want to do any of these heap questions. I have to implement my own heap. I mean, I guess. Oh, we're out of music. Mafu. I need to find one that should be safe for stream. I think I used this one last time. Yeah, when I was doing the game jam game. Okay. Should we do dynamic programming? What's one they haven't done? Maybe an easy one to warm up. Each time you can either climb 1 or 2 steps, and how many distinct ways can you climb to the top? Okay. Okay. You're climbing a staircase. It takes n steps to reach the top. Each time you can climb 1 or 2 steps, and how many distinct ways can you climb to the top? We'll just draw our funny staircase just to... Alright. So 1. And then 1. But there's also 1 plus 1, so there's 2 ways to get to here. Since there's 2 ways to get to here, and actually we have this one, 1 plus 2, because there's 1 way to get from here to here, so 3. And for this step, it's actually, what's it? It's 1 or 2, so it's sequence of n minus 1 plus sequence of n minus 2 is 5. That's it, right? Right, n equals 1 is 1, n equals 2 is 2. So we'll make an array. Stairs array equal, we'll add the base cases, so 1 and 2. This is going to be, I guess it's a 0 at the beginning, right? There are what does that actually look like from here? How many yeah, the base case would be what, 0, right? And also 0. For n minus negative, so this would be like what, negative, index negative 1, index 0, this is 1, okay, index 1, so index n. So we can just build this array, right, with a for loop. For let I equal 0, so this is 0, 1, 2, index 0, index 1, index 2, for I equals 3, I is less than or equal to n, I plus plus. Right, stairs array of I equals, I mean, I guess it could also be dot push, but this is should be equivalent. Actually, just to, you know, be more correct with other languages. Stairs array of I minus 1 plus stairs array of I minus 2. And return stairs array of n. Right? This is a 0 step, this is the first step, this is the second step. At step 3, we check step 2 and step 1 and add those together. Alright. But also n is only up to 45, so we could just, you know, build a table and cache the entire frickin' thing. I think in C, if you do like, it's like what, const expression, then you can let the compiler like do everything in compile time. Well, anyway, worry about that later. Oh, I forgot to set the timer. Oh well. Alright. Alright. What's another dynamic programming problem? Word break. Given a string s and a dictionary of strings word dict, return true if s can be segmented into a space-separated sequence of one or more dictionary words. The same word in the dictionary may be reused multiple times in the segmentation. You are allowed to reuse a dictionary word. Cats, sand, and dog. Huh. Huh. Okay, so it has to, like, be made of dictionary words. Interesting, interesting, interesting. Whoops. Interesting. Same word may be used multiple times in the segmentation. Actually, let's look at the third example. That's a bit more interesting. Cats and dogs. Cats and dog. Whoops. Cat and dog. And this can't be segmented with the given thing. Like, there's two possibilities at the beginning though. A cat, and then all strings in word dict are unique. Only lowercase English letter. Okay. Cats. So yeah, cat is valid here, and then cats is also valid here to segment it, which leaves sand dog, and this leaves and dog. What's and dog? No. Should just replace this example with cats up dog. Okay. So we have sand, dog, sand, and yeah. So I guess we would check all of these if there's like a string prefix. What is up dog? Not much. I think when I was like thinking about debuting in Flavor and like posting my first tweets, I was considering, I was thinking about making an up dog joke. Anyway. Cat, sand, dog, cats and dog. Sand matches, so sand og, and then for this one and also gives og. So it's just true or false, right? So we can just check, I guess we need to check all of these possibilities. Hence dynamic programming. Okay, so we need to store stuff in something. Use a queue, maybe? Nah. We want to remove the duplicates. Hold on. What are we doing here? What are we doing here? we're going to need to store cat sandog, the full string. Then when we do cat, then we need to store sandog. Then we need when we do cats, we need to store andog. And these don't have to be, these could just be like indices into the original string. Then it's like that index is reachable. So 0, 1, 2, 3. So 3 is reachable, and then I guess 4 is reachable. And if, what does that mean? If the index at the length is reachable, then we have true. Then it can be segmented. Okay. So what does this mean? We start with 0, 0 is reachable, so from 0 we check the substring here, compare it to the words in the word dict. And then if the substring matches, then it's reachable. So store that index to be processed later. I guess it could be a queue or something. Could be a stack too. I mean, if I forget the hold on, MDN array. But we don't want to include dupes. Oh, okay. Wait. Wait, could we get dupes? Oh, or I guess we get a dupe here, right? So from sandog, we find sand. So 0, 1, 2, 3, 4, 5, 6, 7. And we find that twice, so how are we handling that? That's index 7. Where's that? Wait, 0. Yeah, 7, the 8th place. 8 and 9. So if we find 9, then we win. Then we have a word that can be segmented. No, I didn't even set the timer. All right. All right. All right. Same word in the dictionary, maybe we use multiple times. Yep, okay, yep. Do we use a set and then like... That seems... I guess we could. Yeah, we could just use a set to store the indices we already processed. But this was like a dynamic programming problem. But the core of it is like not redoing the work when we've gotten to an index. So actually, we could start from the end too. We could start from the end. I don't think it matters though. I think it's the same either way. Store something. Store something. Store something. We can just store the indices. The only thing that matters is that we aren't processing duplicate indices and that we also process each index at least once. Okay. Sorry about that. Hello. I'm still thinking. Right, we're storing that we're... Huh. Could just use an array or something, right? What would that look like? It would look like... It would be as long as the string. It seems unnecessary though. Like we just want to store at least one copy of each value and then process each value once. And then not process duplicates. Oh. Could use a queue in a set. Yeah, I guess. Or a stack. I mean, I'm not sure if JavaScript has a... I think you can use the array as a built-in queue. Just double checking MDN array. There's a... what was it? Push, reduce, reverse, shift? Was it shift? Removes the first element and returns that removed element. Yeah, shift. So then you call push and then you call shift. Yeah, so if you want to use an array as a queue, you push into your shift. I don't think it matters whether you use an array or a stack or a queue here, because we just want to not process duplicates. So let scene equal new set. That's so we don't add duplicates to the queue. And then by processing, I mean we start at the given array. Add 0 to it. For every word in wordDict, we check if the beginning substring, I think that's string slice, right? MDN string. Slice. Extracts a section of the string, returns it as a new string without modifying the original string. Index start and index end. Exclusive. End is exclusive. Okay. If index start greater than if index end is greater than string length, extracts to the end of a string. Okay, cool. Well, q.length. Technically don't need to put that greater than 0, but okay. I guess I can add 0 because S0 is seen. That doesn't actually matter though. For let word of word dict const word. So for each word in the word dict, if s dot slice from const start index equals q dot shift. Shift is what it's called. Okay. So string slice of start index and then start index plus word dot length equals, and that should be a string. Well, if that is equal to the word, then q dot push. If not, okay, const new index is start index plus word length, right? So for apple, pen, apple, that would be apple is length 5, so that would be 0 to 5. 0, 1, 2, 3, 4, 5. Yeah, 5. Right, so start index plus word dot length. Calculating that twice, so maybe move that up. And like maybe check a new index. If not seen dot has new index and slice is equal to the word, then q dot push new index and then scene dot add new index. Okay, so this should loop over everyone once. And actually here we can do the, if we're at the end, if new index equals s dot length, then we're at the end. Then we return true. We found a path, and then we return false. I think that works. Somehow that didn't feel very dynamic programming for the dynamic programming category. Let's see. Hey, we did it. 1140. Oh. Okay, it's been 3 hours. I'm getting a little tired. I think I might end it for today here. But let's just see what other people submitted or solutions. No for loop inside recursion. Super easy and clean code. Oh, in Java. All right. This will always form a unique key. Memo.contains key. Memo get key. Oh yeah. Huh. Okay. I don't understand this. I mean, maybe if I spent the time to read and understand. Oh, it's recursive. Interesting. Okay, it's memoized recursion. All right. What's this one? Let's see, Python. Current in memo, return memo. Yeah, it's recursive. Word in word current that starts. Man, you have a Python has a starts with function. That's convenient. Wait, don't tell me JavaScript doesn't have starts with function, does it? Oh no, it does. It does. There's a starts with function. Oh man, that's on me for not knowing about these super convenient helper functions. Oh, I still have Paint open. No. I could have just used this. Oh well, it's not that bad. S.slice equals triple equals word. Yeah. It's fine. It's fine. Anyway, if current starts with word, new current length word, yeah, string slice. Instead of storing indices, then they're storing the substrings. Yeah. Okay. Yeah, memoized recursion. Also memoized recursion. Bottom-up dynamic programming. In the recursion. It's also memoized recursion. Wow, okay. Weird DP solution? What am I looking at? This also looks like recursion. Word dict. It is length s. Yeah, using the indices at cache. At cache? Is that temp equals for an word dict? Temp equals temp4. DP index +1 empty string. Huh. Okay, I do not understand this. Great. Time complexity of the brute force solution, which would be to the yeah. Tree DP with Q. Construct a tree of all the words. Damn. I mean, that does find it, right? Yeah, make a queue of indices. Build the entire tree and then... Huh. Okay. Alright. Alright. Yeah. I'm satisfied with this solution. There's not much memoizing, or just like processing each index once instead of like, you know, caching stuff. So I kind of solve this differently from, well, most of these other ones. Looks like C#, easy to understand. N times K. I don't understand this. Bool array. Like a bool array. Bools of length -1. Huh. Bools of I return bools of 0. Okay, I kind of understand this. It's interesting. Start at the end. Find if there's a string we can make of it, and then set the bools of I is bools of I plus word dot length. So the end is true, and then for each index in the string going backwards, then if this is like the what's the word? The one after after you use the word, after you substring the word, then set it equal to that. If that's true, then break, because we don't need to loop over the other words. Oh yeah, I could have used a break here, actually. That would have saved a bit of time. Actually, let's see. How much that changes our runtime complexity. Or, well, wrong answer. Oh, right. No. Okay, yeah. No. I have to loop over all the words. Yeah. Okay. No. Okay, not doing that. Yeah, with my solution. Because they're different lengths. Since we're using the bools array here, then yeah, we can check that. Can you? Oh, right, because it's for the current, yeah, like the target index, sort of. But going from the right. And then return bools of 0 is like the beginning of the string. Okay. Okay. 3-hour stream. Think we're gonna end it here. I'm like a little tired, but yeah, I feel okay. I do feel like it's important. I've heard other content creators like talk about this, or well, I think Primogen especially has talked about how if you want to get good at programming, you like really have to love doing it. Because if you don't love doing it, then you're not gonna want to put in the effort to get super good at it. I've been watching Freerun recently. There's that one scene where she's like asking Fern, do you like magic? And then Fern's like, sometimes. And then Freerun's like, you're just like me then. So yeah, sometimes I love programming. There's those moments where you're like, the understanding comes through, and you have that light bulb moment where you suddenly understand something, and you've like solved a really difficult problem, and you feel really good about yourself. I feel like it sort of feels like I'm chasing the high of when I was newer at this and had more of those moments more often. But yeah, I still have those moments occasionally. I still enjoy it somewhat. You know, if you're doing it every day, like, you probably don't love every part of it, but there's still something enjoyable about it, even if you don't love it all the time. If you love it sometimes, then that's good. Hold on to that. Can't love it without hating it sometimes. Yeah. JavaScript. It's such a funny, quirky language. Real. Anyway, thank you all for coming. Thank you, Cyclocus. Thank you, JPZ. Thank you, OT4U. Thank you, Rika Paprika. Thank you, The Best Badness for 20k. Alright, good night. Enjoy the stream. Take care. 07. 07. Thank you, Cyclocus. Alright. Let's see. Is there anyone online to raid here? Here, I can hide my thing. Juwon's live. Juwon's doing karaoke. All right. Here's our unofficial raid. All right, go raid Juwon. Go click the link. All right, Otsu Neo. Bye bye everyone. Good night. Thanks for stream. Thank you, JPZ. Good night. I hope you all enjoyed it. Hopefully you can have fun watching me do these programming problems and just talking about stuff. All right. Bye-bye. Bye-bye. It's Neil. Bye-bye.